This video is over Lesson 58, Probability and Chance. Take a moment to copy this down into your notes. Moving on in 3, 2, 1. Probability is how likely an event is to happen. Mathematically, it can be calculated by taking the number of favorable outcomes and putting it over the number of possible outcomes. Here, favorable means the number of outcomes that we're looking for. For example, if we're talking about flipping a coin, and I want to know what is the probability of flipping heads. Well, when flipping a coin, there are two different possibilities. I can either get heads or tails. So if I want to know the probability of getting heads, then my numerator is going to be how many favorable outcomes are there. Well, with just heads and tails, obviously heads is the only one that's favorable. So 1. How many possible outcomes? Well, heads and tails. So there are 2. So the probability of flipping a coin and getting heads is 1/2. How about the probability of rolling a die? So let's calculate the probability of rolling a 3. So if you consider a die, a single die, there are 6 possible outcomes. 1, 2, 3, 4, 5, and 6. So the numerator is actually a little bit easier to find there to start with. Now, for the numerator, I want to know how many outcomes match what I'm looking for. How many of them are favorable? Well, if we're trying to find the probability of rolling a 3, how many of those outcomes are a 3? Well, only one is, the 3 itself. The 1, the 2, the 4, the 5, and the 6 are not what we're looking for. So the probability of rolling a 3 is 1/6. Let's also find the probability now of rolling an even number. Again, the denominator is going to be a little bit easier to find. The number of possible outcomes, well, 1, 2, 3, 4, 5, 6, there are 6 of them. For the numerator, we need to consider how many are even, how many are what we're looking for, are favorable. So in 1, 2, 3, 4, 5, and 6, 2 is even, 4 is even, and 6 is even. Well, that's 3 favorable outcomes. And if we reduce our fraction, we find out the probability of rolling an even number is 1/2. Moving on in 3, 2, 1. All probabilities fall within 0 and 1. A probability of 0 means that the event is impossible. A probability of 1 means that the event is certain. It will definitely happen. And then in the middle, we have a probability of 1/2. And a probability of 1/2 means that the event is just as likely to happen as to not happen. In between here, events that have a probability between 1/2 and 1 are more likely. The more and more they grow towards 1, the more and more likely they are. To the point where something that is over here would be very likely, almost certain. Whereas something that's just above 1/2 would be a little bit more likely to happen than to not happen. On the opposite side then, the closer we get to 0, the less likely something is. So if we have an event whose probability is nearly 0, well, it's not impossible, but it's nearly impossible or almost impossible. But if it's just a little bit under 1/2, then it's a little less likely to happen than to happen. Moving on in 3, 2, 1. Finding the sample space of an event can be very helpful for finding its probability. And the sample space is the set of all possible outcomes. Here the word set really just means collection. So if we go back to our previous examples, flipping a coin, we're looking at the collection of all the possible outcomes. Well, in mathematics, when we have a set, we use brackets around the set. So there's my starting bracket. Well, if you flip a coin, it's either going to be heads or tails. So I'm going to use capital H for heads. I'm going to put a comma in between each of my different outcomes. And I'm going to put a capital T for tails. Closing bracket. And there's my sample space for flipping a coin. So if we think back to the probability of flipping a coin and getting heads, well, there's one of these that's a heads out of 2. So probability is 1/2. Now let's look at the sample space for rolling a die. Well, let's start with the opening bracket. And when we roll a die, we can get a 1, a 2, a 3, a 4, a 5, or a 6. And that's it. So there's my sample space for rolling a die. So the probability of rolling a 3, only one of these is a 3 out of 6 total possibilities, which is why the probability of rolling a 3 was 1/6. Or the probability of rolling an even, 2 is even, 4 is even, 6 is even, there's 3 of them out of 6 total, so 3/6 or 1/2 probability of rolling an even. Moving on in 3, 2, 1. Chance is directly related to probability. In fact, really all it is probability written as a percent. So first of all, let's consider our range for probabilities. Probabilities can be anywhere from 0 to 1. So if we change those into percentages, that means that chance can be anywhere from 0%, meaning that something's impossible, to 100%, meaning that something is certain. And if it's just as likely to happen as not happen, it's a 50% chance, which is where we get the phrase, it's 50-50. 50% it could happen, 50% it would not happen. If we take the probability of an event and multiply it by 100%, that will convert our probability into chance. So if something has a 3/8 probability of happening, we can convert this into chance by multiplying it by 100%. Well, now I have a fraction times a whole number, so in order to do this, I'm going to take my 100% and turn it into a fraction, making it 100% over 1. As we've learned in previous lessons, if we can reduce any number on top with any number on bottom, it'll make things easier for us. So I'm going to reduce both of these by 4. So 4 goes into 8 twice, 4 goes into 100 25 times. I can't reduce anymore, so we got to multiply. 3 times 25% is 75%. And then 2 times 1 is 2. Do a little bit of division. 75 divided by 2. So 2 goes into 7 3 times, which is 6. Subtract and we get 1. Bring down my 5. 2 goes into 15 7 times, which is 14. Subtract and we get 1 again. But this time that 1 becomes part of a fraction, so 1/2. Therefore, a 3/8 probability is a 37.5% chance. Moving on in 3, 2, 1. Complements are opposite events. Their probabilities always add up to 1. For example, if we're talking about the probability that it will snow today, then the complement would be the probability that it's not going to snow today. If we're talking about the probability that the sun is shining, then the complement would be the probability that the sun is not shining. If we want to talk about the probability that school will not get out on time, the complement would be the probability that school will get out on time. And because they're opposites, either one of them is going to happen or the other. And so they cover every possibility. And so their probabilities always add up to 1, because one of them will always happen. It's either the event or its opposite. Always has to happen. So because of this, if we're told that the probability of an event equals 2/5, we should be able to calculate the probability of the complement. Well, if they always add up to 1, that means that 1 minus the probability, in this case 2/5, should give us the complementary probability. Well, 1, as we remember, is really 5/5. So I have 5/5 minus 2/5, which means that the complementary probability is 3/5. So if this is the probability that it will snow today, this is the probability that it will not snow today. Complements can also come up with chance. However, the probabilities in that case really would add up to not 1, but 100%. So, let's say we had a chance of 82%. Well, the complement and the chance have to add up to 100%, which means that 100% minus my 82% should give me the complementary chance, which in this case would be 18%. And this video will end in 3, 2, 1.